Hello all. The topic of presentation is design and simulation of Schmitt Trigger Circuit. In this practical, we will design the Schmitt Trigger Circuit for given specification. Then we will implement the Schmitt Trigger Circuit using op-amp LF356. We will observe the output waveform and we also observe the hysteresis of the Schmitt Trigger Circuit, and then we will calculate the UTP, that is upper threshold point, lower threshold point, and width of hysteresis using the graph. The Schmitt Trigger Circuit will be like this. It uses the positive feedback. R1 and R2 provides the positive feedback. R compensation resistor is used to compensate the losses because of input bias current and input offset current. We will apply the input voltage 3 volt peak to peak 1 kilohertz. Now we will design the Schmitt Trigger Circuit for same UTP and LTP, that is plus minus 1 volt upper threshold point and lower threshold point. For that we will assume VCC is equal to 12 volt, and that's why the saturation value of output voltage will be 0.9 VCC, that is equal to 10.8. The formula for UTP is calculated as R2 into plus V saturation divided by R1 plus R2, and LTP is equal to R2 into minus V saturation divided by R1 plus R2. If you subtract LTP from UTP, you will get UTP minus LTP is equal to 2R2 into V saturation divided by R1 plus R2. As UTP and LTP is plus minus 1 volt, this is called as a width of hysteresis. UTP minus LTP is called as a width of hysteresis, which is equal to 2. By putting the value of 2 in the equation, we will get R1 is equal to 9.8 R2. That's why we will assume R2 is equal to 1K, so that R1 is equal to nearly equal to 10 kilo ohm, and R compensation is equal to R1 parallel RF, which is equal to 1K. We will build the circuit in the multisim software. We will apply the input voltage 3 volt peak to peak. Then we will simulate the circuit and we will observe the output waveform, and we will calculate the value practically. So the circuit is built. We will apply a measurement probe so that we can easily calculate the frequency as well as peak to peak voltage. Then we will apply the measurement probe at the output, and we will observe the frequency as well as peak to peak output voltage. We have applied VCC is equal to 12 volt to terminal 7, VEE is equal to minus 12 volt to terminal 4, R1 is 10K and R2 is 1K. Now we will simulate the circuit so that we will validate our theoretical result with the practical result. So this is how at 4 volt peak to peak 1 kilohertz frequency we have got 22.2 volt peak to peak, that is positive value of saturation is 11.1 and negative value of saturation will be V saturation will be 1.1. If you double click on the oscilloscope, you will observe the input as well as output waveform. Input waveform is sine wave and output waveform is a square wave. You can measure the amplitude of output voltage by dragging the cursor to plus V saturation and minus V saturation. Here we will get 22.23 peak to peak value, 11.11 positive V saturation, and minus 11.11 is negative V saturation. Now if you want to calculate the UTP and LTP, just click on the input waveform and just drag the cursor to the intersection of input and output waveform. Here it is. So you will get UTP is 1.233 volt and LTP is minus 1.22 volt. So this is how we can calculate UTP, LTP plus V saturation and minus V saturation using the cursor on the CRO. Now if you click on XY mode, you can easily observe the hysteresis, without hysteresis. If you follow this arrow, this will indicate plus V saturation, this will indicate minus V saturation, this will indicate plus UTP, and this will indicate minus UTP. And using this also, you can easily calculate almost 1.2 volt is UTP, minus 1.2 volt is LTP, and V saturation is this division, vertical division 2.1 multiplied by 5, same minus V saturation is 2.2 multiplied by 5. So this is how you can calculate the plus V saturation, minus V saturation, UTP and LTP. Now you can put the values in the observation table. Theoretically UTP is 1 volt and practically we have got plus 1.2 volt. LTP theoretically is minus 1 volt and practically we have got minus 1.2 volt. V saturation is plus 10.8 volt, practically we have got plus 11.1 volt, and minus V saturation is minus 10.8 volt, practically we have got 11.1 volt. So this is how we have validated our theoretical readings with the simulation reading. Thank you.